Like I learned a lot. I strongly anticipate this being like the best episode we've ever done. Like it's a good topic. Feeling thirsty for knowledge? Hackers on the Rocks is the podcast that mixes refreshing conversation with potent cybersecurity insights. Serving up these insights with a twist, we pair a different software vulnerability with a refreshing cocktail recipe each episode. All right, hello world and greetings all around. Our opening segment is called Get Handle Information, and here to bring you today's drink, our guest, Louis Nyffenegger. Louis, what are we drinking today?
So today we're drinking beer. We're drinking Belgian beer, Leffe, because that's one of the beer I really liked, and that reminds me when I was at school and like drinking beers at night and playing Urban Terror, which is like kind of a Counter-Strike clone based on the Quake engine, and that's the only thing that we could play on Linux. So that's what it reminds me of, and yeah. And it's good beer.
It is good beer, and I also have some fond memories of Counter-Strike. So yeah, or equivalent. So rock on. All right, I have my left, and you have yours.
Yep.
All right, let's crack it. And I guess you kind of alluded to this, but while we're drinking, I guess just tell us a little bit about yourself, how you got in the research community, how you expanded from Counter Strike and Quake to cybersecurity.
So I started when I was at in university and engineering school. I started to look at things and trying to understand how they were working and putting things apart. And I realized that when you understand how things work, it's really fun to then break them. And that really like drive drove me because I really enjoy understanding things like as an engineer, like trying to like really put apart little details. And it feels like breaking them once you understand them properly is that extra little step, trying the thing that people who build the stuff didn't think of. And that drove me to security more and more. And then everything else is history, I guess. I kept going for a long, long time now.
Yeah, no, I appreciate it. And all right, so in the pre-call, you shared with me that you are originally from France, and you've landed kind of in Melbourne. So
Yeah.
how do we toast to each other in language of your choice?
I don't know. Oh, maybe we can do in French. We can say à la tienne.
À la tienne.
Yeah.
That is delicious. I'm definitely a fan of the sweet beers, and this is a very good one. So thank you for choosing. All right, let's dive into it. But first, this episode is brought to us by IO Active, a trusted partner for Global 1000 enterprises. IO Active provides research-fueled security services across all industries. Its cutting-edge security teams provide highly specialized technical and programmatic cybersecurity services, including full-stack penetration testing, program efficacy assessments, and hardware hacking. IO Active brings a unique attacker's perspective to every engagement to maximize cybersecurity investments and improve the security posture and operational resiliency of its clients. All right, this segment is called the distillery, where Louis will take some research and distill it down into terms that are fairly simple, so we can understand what he's talking about. So, Louis, what are we talking about today?
So we're going to talk about JSON Web Token algorithm confusion. So
All
it's
right.
kind of a full mouth, but we're gonna get there.
Yeah, so we'll start. I guess let's start backwards. So JSON. I mean, start this over again. So JSON Web Token algorithm confusion. All
Yeah.
right. So we have I've seen JSON Web Tokens as JWTs. I'm sure we'll be talking about that. So let's start backwards, right? So in terms of algorithm confusion, right? How does software get confused? Like where does the confusion part of algorithm confusion come into play?
So when you have signed information, uh, you need to have an algorithm to verify that signature. So for example, if you're using HMAC, you're going to use HMAC to sign and HMAC to verify. When you're using RSA, you're going to use RSA to sign and RSA to verify. And same thing with elliptic curve. The thing is that with some format, or specifically with JWT, part of the format contains the algorithm that is used to verify. So this is when you sign the token, you say, okay, that token was signed with that algorithm. So that way, the person verifying the token know what algorithm to pick. The problem is that as an attacker, you have control over that part of the token because this algorithm need to be retrieved from the token and then the signature is verified. So this happens before the integrity check is in place because you need the algorithm to verify. So you need that's happening before. So that's how algorithm work in JWT. So as an attacker, you control the algorithm. Where the confusion is coming in is that what you can do is, as an attacker, I'm going to say, oh, this token is not signed with this algorithm. It's signed with this other algorithm. And the classic example of that is you have a token signed with RSA, and you're going to say, wait a minute, as an attacker, I'm going to say this token is signed with HMAC. The person verifying the system or the person verifying the token will try to verify it with HMAC. And if the library or the application is vulnerable to algorithm confusion, you will be able to forge your own token just by changing this algorithm and doing a bit of crypto on the side. But that's the gist of it.
So I'm going to pull this back to like 15 different questions because there's a lot. Let me make sure I understand the overall concept. So when we talk about algorithm confusion, we're not talking about necessarily overall code flow. What we're saying is data is provided to a server and the system is making an assumption about how that data has been digitally signed, right? And so there's different approaches. You mentioned an RSA algorithm that could be used. You also mentioned an HMAC algorithm. And the vulnerability exists essentially when we claim as the attacker, we assert which algorithm we are using, and the server just says, yeah, that's fine.
Yep.
Is that correct? Okay. So let's back up a little bit. So in terms of RSA versus HMAC, I guess let's start there, right? So if I heard you correctly, like we're downgrading from RSA to HMAC, like what makes it a downgrade? Like what's the difference between those cryptographic methods?
So that's not a downgrade. That's the interesting part about it, is to understand the attack, you need to look at what source code will look like. So if I'm using HMAC, I'm going to sign with HMAC and with a string, ABCD, whatever, or secret. When I'm going to verify using HMAC and the same secret, ABCD, whatever. When I'm using RSA, I'm going to sign with the private key. And that's going to give me a signature with RSA. And when I verify, I'm going to verify with the public key. So now, if you are a JWT library, when developers use your library, they're going to say verify, and they don't necessarily specify the algorithm. They just say, okay, verify with that secret or verify with that public key. What they think is happening is if they're using RSA, they think it's going to be RSA.verify with the public key. If it's signed with HMAC, HMAC.verify with that secret. But since we control the algorithm, the application, the developer thinks it's going to be RSA.verify with the public key. But what is happening, since we control the algorithm, we can say, actually, use HMAC.verify and the public key. And by definition, the public key is public. So you can find a way to retrieve the public key, and you have everything, like you have all the ingredients for the recipe. You control the algorithm, you have the public key, so you can forge your own signature, and then it's your own token.
Got it. Okay, I think I understand. So essentially, and we've not gotten into JWTs and where they're used, which I will get there, but the idea is I am sending to a web server, hey, here's some information, and you know the information is legitimate because there's a digital signature on that information. And what we're doing is we're saying, as an attacker, we're saying the digital signature was produced using, we define the algorithm. We, as the client, define the algorithm, and the server says, oh, okay, we'll use the algorithm that you're suggesting. And the weakness exists when I can essentially use an algorithm like HMAC, where we're simply providing plain text information in the form of a public key, which is by definition public. We're echoing it back to the server saying, this is what you need to use, essentially as a symmetric key. And because we know that it's not really a secret, we found it, and we're telling the server, use this as the encrypt, as the, the secret part of our symmetric handshake, no, actually our symmetric exchange. The digital signature will work. Therefore, the information I'm sending you is legitimate information. Is that what's happening?
Exactly, except we don't provide the public key. The public key is already in the code of the server.
Got it. So it's just saying,
Yeah,
look up this key, and if you find it, then we're good, essentially.
yeah, or that's the key you always use to verify. But usually, like in a legitimate scenario, you use RSA. But for us, you're going to use HMAC.
Okay, so we're the vulnerability exists basically by telling the server it's going to use something that it really shouldn't be using, and it just saying okay, like it is the server is not informed. Okay, yeah,
Yeah.
it's the audio show. You're smiling, so I think I've got something. So maybe let's go a little bit further back. So this is all in the context of something called a JWT. Can we talk about
Yep.
what that is and where that would be used?
So JWT tokens are something that it's a terrible format that all developers decided to adopt.
Okay, great.
So why it is a terrible format is so the problem with JWT is that it's trying to be crypto agile and make allow developers to like swap algorithm, change algorithm, and support different signature mechanism like HMAC, elliptic curve. And it's a lot of decoding before we actually verify the data. And all of that make the format really, really hard to get right. So if it's hard to get right, people get it wrong. And so you probably have seen JWT before is, so it's base64 encoded JSON with three parts. So something that looks like EYJ, a lot of data, a dot, EYJ, a lot of data, and then more base64 encoded data.
All
And
right.
if you solve this, it's a lot of fun.
Okay, got it. All right. So I am a web client, and I am trying to send data to you that represents authentication. And that's the JWT, right? J is JSON. So it's
Yeah.
everything JSON formatted structure. And then in terms of web token, it's really sent as an HTTP header. And if I heard you correctly, there's three parts. So essentially, because it's HTTP, it has to be plain text. And so we're sending header information, and then we're sending payload information, and then we're sending that digital signature. And
Yep.
it's all base64, it's all plain text, right? So the encryption is handed somewhere else, like TLS or something else. And so an HTTP header is joining our client request, dear server, I want you to do a thing. And oh, by the way, like here's the authorization that lets you know that I am who I say I am, and that I have authorization to run the request, right? And so I think this is really timely. Like we just had an episode where Katie Paxton Fear came, and she came on to talk about API security, and she was talking about authentication abuses, and I feel like we didn't cover a whole lot about how JWTs are part of the process, and so I feel like we're getting that now, and so I guess well, let me back to that. So like the question I think for you then is like, I agree with you. It seems weird. Like we're using plain text authentication, and we as the client are sending it. They're interceptable. They're forgeable. Why? Like why is this the why are we doing this to ourselves? Like
because it got adopted so quickly and people found them like really handy, really easy to handle, a lot of libraries in a lot of languages, and developers start using them. And then everyone were using them, everybody was using them. So we like, yeah, it's everywhere now. It's kind of like the format everyone is using, despite people complaining. And there also have like, there also is like some alternatives like Pazeto, but no one is using them. So,
Got it. Yeah,
and
and
like,
yeah, and I hear you. I think one thing that Katie had talked about was like the statelessness of it. And so now the server isn't responsible for storing the session info, the client is. And like I hear you, right? It's easy, it's plain text, it's easy to scale and distribute. But I've always thought, and we've had several guests on various episodes, talking about, well, if the server's not doing the validation, but the client is, like, that's just ripe for error. And so, all right, so now we at least understand the environmental challenges, right? So I, as a client, I'm sending something out. There's a digital signature, but we can perhaps compel the server to just let us do something that we would want. Um, let's say we find a piece of code that's vulnerable to this. Like, what's the impact?
so basically, so I built a lot of labs around JWT, and what I usually put for people to learn is you can register as any user, and in the token you get your username, and then you change that to administrator, and you become administrator. It's like having a magic form where you can just put the username you want to become.
Got it. Yeah. So, all right, that sounds pretty impactful, right? It sounds like elevation of privilege, definitely
Yes.
tampering of data, disclosure of data. From your perspective, then, as a researcher, right? How do you find these? How do you know that a server is vulnerable to this kind of an attack?
So if you are looking at source code, you can audit the source code to find the issue. If you are attacking like a real application where you don't necessarily have the source code, um, one of the first steps is you can recover a public key from a signature. So there is a tool. It's linked on one of the blog posts I wrote around like how to do that for RSA, or it's linked in one of the labs. But so we can go from a signature to a public, no, multiple signature to a public key using RSA. So once you got the public key, you can just forge your own token. Say, okay, this is signed with HMAC, and use the signature, use the public key to sign the token, and then you send your magic token. If it's signed with elliptic curve, what you can do is get from one signature to two public keys. So two potential public keys, and now you just have to test both of them. This is actually how cryptocurrency work. Like if you look at Bitcoin or Ethereum, like the transaction does not contain the source address. The source address, the public key used to sign the transaction, you can recover it from the signature. So we do exactly the same thing. We
Got
recover the public key from the signature, and then we forge our own token.
Got it. All right. So you're obtaining a JWT somewhere. You're sniffing traffic. However,
Mm.
you would be in the middle of that. You're analyzing it, and then you're starting to kind of tamper and basically just tinker and see if the server accepts what you're throwing at it, right?
Exactly.
And I guess where I'm trying not to get scared, but when we talk about JWTs and being used as part of API authentication, how prevalent do you feel like JWTs are? And then as a derivative question, how common do you think this kind of vulnerability class would exist um, in the wild in various applications?
So JWT are pretty much everywhere with API. It's pretty much, in my opinion, rare to find API that don't use JWT, but feels like that's a kind of default authentication mechanism for a lot of them, especially if they're using OAuths, like you're like a ton of API using JWT. The good news for developers or the bad news for hackers is that this kind of jailability algorithm confusion are still very rare because um, most of the time, modern libraries force developers to pick an algorithm. They don't use the algorithm in the header. They tell developers to say like, if you want us to validate token, you need to give us the list or the one algorithm you will trust. And by doing that, they kill this attack, and they also kill the JWT non-algorithm attack by just having libraries that force developers to say like, okay, this is the only algorithm I'm going to trust. And
Gotcha.
that completely kills the attack.
And real quick, you just said the none. Can you define what the none means?
So not only do you have JWT algorithm confusion with JWT, but as part of the specification, there is an algorithm named none, which is basically no signature. So
Mm,
we have this signed token format, which has a signature mechanism that is none. And it's not much of an issue currently as it used to be, but a few years back, libraries had support for the non-algorithm by default because it was defined in the RFC. So they had to implement it, but they had to disable it by default, but no one was telling them to do that. So someone realized that, oh, all these libraries support a non-algorithm, and that's not a good idea.
yeah, that sounds
And
horrible.
yeah, and the scary thing is that as a developer, you just trust the library to do the right thing, and you think like on the HMAC it's going to work, or on the RSA it's going to work, and there is like this kind of backdoor algorithm that works, and you never heard of it, and yeah, so it was pretty scary at the time. But I don't think there are a lot of libraries that are vulnerable nowadays. I'm
Got it.
touching wood. You can't see.
Yeah, fair. Okay. All right. So when we talk about algorithm confusion, then I think to your point, like we're not actually downgrading anything. We're not cracking anything. There's no real cryptography here. We're simply telling the server, hey, can you just use your public key? And it says yes. And we're kind of done. So it's really it's a hit or miss kind of thing. There's we're not doing any magical again cracking or tampering with data or manipulating pointers or anything super fun.
Mm,
Got it.
no, that's really so there's a bit of tempering of data, but nothing really hard. It's just basically for decoding data, and that's why I really like teaching is this kind of breaking crypto without being like a math wizard,
Yeah.
just doing the right thing and understand. And I think it's really good for people to understand like the threat model around it. It's like, okay, the application trusts, the library trusts the algorithm, so we can tamper with the algorithm, change it, and since all of that is happening before the signature verification, we can forge our own token. And I think that's a complex, beautiful attack, and I think that's a really good way for people to understand like crypto engineering and how things can go wrong.
Yeah, I totally agree. I think I'm not when we pick the episodes, we're generally picking them based off of real world research mapped to the MITRE CWE list of those common weaknesses and enumerations and algorithm confusion bugs pop up. They're in that list. They're not necessarily in the top 25, but I had no background in this, and it's a fascinating subject. And your posts and blogs are really articulate on it. So I definitely appreciate you sharing. Anything that we haven't mentioned yet or hasn't been said yet about algorithm confusion bugs that you want to bring up before we come to a close?
I think that's something that I don't think it's going to work, but I think that's also something that could potentially apply to SAML. And there hasn't been that much research on that. So that could be an interesting thing to look at. And yeah, I think it's really good example of attack that are not necessarily like everywhere, and you're gonna sometime be lucky and find it, and then you're gonna be very happy. But there are attacks that really makes you better as a security person because you understand a lot more about crypto engineering and all these things. And I think that's really worth like reading the blog post to like understand them better because it's hard to explain like that talking about it. But yeah.
Yeah,
It's
I
a lot of.
agree. I agree. I think the conceptually, it's a lot easier when everything is plain text and then encoded in different formats than when we're dealing with pointer arithmetic and buffers and parameters. So I think it's a really good topic for researchers to kind of dip their toes into some of the research. Real quick, since it's kind of the nature of our show, since you mentioned using JWTs for SAML, can you just define what SAML is and how awful it would be if there's a algorithm confusion bug in one of those applications?
So in SAML, you will use like instead of using JSON like JWT, you will use XML, but you can still tell how the message was signed. And that's potentially, so since you can tell how it was signed, you kind of end up with the same kind of issues. And I don't think there's been like a lot of research on that. SAML is what you use when you are doing like authentication with, for example, enterprise authentication, single sign-on.
Yep.
If you see like big blob of base64 and then you decode them and you get like big, even bigger blob of XML, that's SAML.
Got it. Okay. So this is now you're looking at this for basically anything that's network logon enabled.
Yeah.
Azure Active Directory is probably like the big one that would come to mind. Okay. Very cool. I appreciate it. So, Louis, where can people go to find out more about you, your work, anything you mentioned today?
So pentesterlab.com, like if you're looking like slash blog for the blog and everything I'm writing on, pentesterlab.com if you're looking for training for enterprise individual. I also do more and more security code review training. So same pentesterlab.com. That's everything I do.
Yeah, rock on. Thank you. Thank you so much, Louis. I really appreciate you taking time out of your day to do this, distilling down algorithm confusions for our audience. Congratulations on the research on the posts. I appreciate it. You made this really simple, and it's a fascinating topic. So I really thank you.
No worries. Thanks a lot for having me.
Yeah,
And
help me one more time. How do we kick this off with the cheers in French?
à la tienne.
À la tienne. All right. Thank you, sir. À la tienne. Yeah.